few more terminologies which you need to be familiar with in regarding to geometry before we learn anything concrete in geometry. Here I have a initial arm. Now if I rotate the arm like this, right? If we happen to rotate the arm, what happens? It keeps on increasing or decreasing, right? So there is a name for particular position. For example, which you guys already, I'm sure you know about this, making an angle of 90 degree, right? If this entire thing is divided into 360 parts, so 1/4 of this angle, this entirety, if we swipe 1/4 of the rotation, complete rotation, it is known as 90 degree right angle. So there are other names that we need to be familiar with, which will be part of your day-to-day usage in geometry. So first we'll begin with, if the initial arm is over here and it happens to rotate more than 180 degree, okay, of course less than 360 degree, so we have something called as reflex angle. So this will be between 180 and 360. If the angle happened to be till here, that is till 180, this is known as straight angle. Then if the angle happens to be between 90 and 180, this is known as obtuse angle. If the angle happened to be 90, it's known as right angle, and between 0 and 90, so this is right angle, and between this region, okay, let me use some other color, between this region, okay, between 0 and 90, it is known as acute angle. Okay, right? So these are the names that you need to know. Just have a look for a second. So let me repeat the entire thing. If this is the initial arm, if we happen to rotate more than 180 degree, let me write it over here. If the angle happen to be more than 180 but less than 360, you have your reflex angle. If it's just 180 degree, exactly 180 degree, it is your straight angle. Between 180 and 90 degree, it is your obtuse angle. So between less than 180 but more than 90, and between 0 and 90, between more than 0 but less than 90, acute angle. Okay, so this is your, okay, let me write it over here itself. This is your acute, right, obtuse, straight, reflex. So this is your answer. Okay, so again, all of this, yes, you guys know or might have known or confused, but you should be sure of it, right? Let me not waste more time. Next thing which you guys again keep forgetting, and it's not very common, it's not used very often, but again in tricky questions you need to know this. So complementary angles. So I have an angle and I have one more angle. Wait, how does it look? Yeah, something like this. Okay, if this is x and this is 90 minus x, if I happen to add this to, if I add this to, how much will we get? 90 degrees, is it not? Right? If I call this as a And if I call this as angle B, what is A plus B? Angle A plus angle B is equal to 90 minus x plus x, which is equal to 90 degree. So these two angles are said to be complementary to each other. Okay, two angles are said to be complementary if they add up to 90 degree. They can be any random angle anywhere. Not sharing anything, sharing something doesn't matter. Two angles are said to be complementary if they add up to 90 degree. Okay, next, something like this. I have one angle over here, something like this, and another something like this. So if this is B and, okay, let me call this as x again, and say this is 180 minus x. So if this is B and this is A, here angle A plus angle B is equal to how much? Well, 180 minus x plus x, which is equal to 180 degree. So this is supplementary. So two angles, when they add up to 180 degree, they are supplementary to each other. They supplement, they supply what? Supply with the other part of the angle, thus making it 180 degree. Okay, again, complementary angles are angles that add up to 90 degree. Supplementary angles are angles that add up to 180 degree. Important note, the angles need not be adjacent to each other. That is, they need not be neighbors to each other. And about the language, angle A and angle B are complementary or supplementary to each other. So that will be the language. Angle A and angle B are said to be complementary if they add up to 90 degree, or angle A and angle B are supplementary if they add up to 180 degree. Okay. So if you want to remember this, right? So you can remember it this way. There are two ways actually. Supplementary starts with S, complementary starts with C. So if we do this, you get 180 degree. If we do this, you get 90 degree. Okay, so that's how you can remember. One more way of remembering complementary is this. Complementary is C, right? Or something like this. Okay, I mean, it's kind of weird, but 90 degree, right? Complementary sitting in 90 degree. Again, whatever suits you guys, you can remember that way. So we have complementary, we have supplementary angles, which have a specific meaning that you need to remember, right? Few more things, not much. All these are things that we need to know, and they're not too complicated. So let's learn it off. So next is adjacent. So I have initial arm and final arm and one more arm. Okay, any random angle, doesn't matter. Here angle A and angle B are adjacent. That is, they share a common vertex, say M, and common arm AM. Okay, so again, adjacent angles are angles which share common vertex and common arm. Two angles that have one common arm and a vertex are said to be adjacent. So angle A is adjacent to angle B. Adjacent means neighboring, right? So these two are neighbors. Linear pair. Two angles are said to be linear pair if they are adjacent and supplementary. So here say x and this is 180 minus x. So clearly they add up to 180 degree, one thing. Second thing is they are neighbors, right? They share a common vertex and they have one arm which is common. So this say vertex is say T, then M, this is N, then this is P. So this is linear pair, right? There are two angles basically which add up to 180 degree and they are adjacent angles. Okay. Next is intersecting lines. So two lines are said to be intersecting if they are not parallel. Basically this, that. It can be anything. So two angles are said to be intersecting if they are not parallel basically. So what is parallel then? Two lines are parallel if their distance will never change between them. So if I measure, say, these two lines distance at any point, say point P, point P1, P2, P3, from here till here, the perpendicular distance will remain the same, remain the same, remain the same. If this is 3 centimeter, this is also 3. This is also 3. So all this distance is 3 centimeter. So distance between the lines are always equal. Okay. So these two lines are said to be parallel. While here, the distance from, if I try to drop a perpendicular, something like this, the distance from point P1 is different than point P2. See, this is perpendicular. Perpendicular is nothing but 90 degree. So the distance from P1 to the other line and from P2 to other line will not remain same. It will be different. So such lines are intersecting and such lines are parallel. Okay, so as promised, I try to finish it fast so that you guys don't get bored. But yes, again, you need to be sure of this. Write it once, you have to write it, no other option. You have to write this once and you have to remember all of this.